Hey, families of functions and absolute value functions. This comes from 5. Oh, it's not 5.6. Sorry, it's 5.4 and 5.5. Sorry. Absolute values functions look a little bit different than quadratic functions. We spent pretty much all of term 2 on quadratic functions. So all the properties you learn on quadratic functions can be transferred over to our other functions. So the essential question is, how are a, h, and k related to the absolute value functions? Is it similar or different to linear and quadratic functions a, h, and k? We know what a, h, and k is, right? When I say a, h, and k? Okay, we're going to start with looking at what an absolute value function is, and then we'll apply it to all the others. Okay, the parent function, PF, each of our functions that we look at have a basic parent function. Parent function is the most simplest absolute value you can find, which would be y equals absolute value x. No extra details on it. Y equals absolute value of x. Okay, we're going to get some points, plot them, and see what the graph looks like. And because I always do vertical xy tables to switch it up so you're used to both, let's do a horizontal xy table today. From -2 to +2. Yeah? No, it's out right now. Okay, we're done giving hall passes. Okay. Remember, we take each of these x's and we plug it into the function. And absolute value means the distance from 0. So what's the absolute value of -2? Because it's 2 units from 0. So distance is measured in positives, right? You can't have a negative distance. Okay? Brian Macias, what's the absolute value of -1? Okay. How far is 0 from 0? 0. What about 1? Absolute value 1? 1, absolute value 2? You see a pattern that happened. We have a repetition because right here we have a vertex. So just like a quadratic, there is a vertex. Okay, let's make a graph and plot these and see what it looks like. You can use the edge of your calculator if you need help drawing a straight line. Our x's only go from -2 to +2, and our y's looks like are all positive or 0. Make sure you put arrows on your axes. Make sure you label x and y. Make sure you have numbers so we know what you're counting by. And then plot the points. You're trying to find out what's the shape of an absolute value graph. Can you hold this? What's up? Thank you. Okay, what's the shape? How many lines are there? I heard someone say a line. How many lines are there? There are 2. There are 2 pieces. One comes down here, negative slope, and then it turns and we have positive slope. And it is shaped like a V, like someone else said. So unlike quadratics, absolute value have linear arms, so every point on the negative slope arm has the same slope, a constant slope, and every rate of change from on the right side, I'll have a constant positive slope. Versus quadratics, the slope is always changing. Okay? So, we have the absolute value. We have some transformations. We also can call transformations, translations, I guess is what I wanted to write first. Translations is the fancy math word for shifts. Transformations is what affects the arms, is the multiplier. So just like all of our other functions, we have an A, an H, and a K. Make your absolute value arms. Sammy, if you need a drink, you can go get a drink. Make sure your absolute value bars are long enough that they don't get confused for being like ones or L's. Okay? I make them nice and tall and nice and long. Okay, so this is absolute value. Maybe, yeah. Do you remember what A does to the graph? We have vertical compressions and vertical stretches. When do we get a vertical stretch? It's not a fraction, nope. When it's greater, when the absolute value of A is greater than 1. Because the fractions could be greater than 0. You have to be greater than 1. If you're equal to 1, it's normal arms. If you're greater than 1, such as like 2 over 1, you go up 2 over 1, up 2 over 1, up 2 over 1. You're getting higher more than you're going out. So that is a vertical stretch. It brings the arms in and gets steeper. I heard people saying fractions. What does a fraction have to be in between for it to be a compression? From what to what? Absolute value of A has to be less than or equal from what number to what number? 0 to 1. And the absolute value of it. So any fractions between 0 and 1 have a vertical compression. When you compress, it oozes out the side, so the arms come down and it looks like it's getting wider. And lastly, A can be less than 0, which is negative. What happens when the graph is negative? It flips. So it does the exact same thing that all the quadratics do. Same effects. So we have horizontal shift, vertical shift, opposite, same. So it's really nothing new today other than a new type of function, but it behaves the same way. So that's the absolute value. Our quadratic function y equals a times x minus h all squared plus k. And then we also have a linear function. Y equals a times x. I'm going to put a plus k. The reason I'm only doing a plus k is what happens if I add something to the x and then I have a vertical shift out here. If I add something to the x and I also have a vertical shift, doesn't that just really all become a vertical shift? That horizontal shift is has the same effect as a vertical shift. So with the linear function, I'm only going to put a plus k, because the horizontal shift will actually also shift it vertically. So we still have horizontal shift, vertical shift, opposite, same. And the vertical shift is always the same if it's outside the function. Does the absolute value AH and K look the same as the quadratic AH and K when it's in vertex form? Does the red equation look the same as the green equation under the quadratic? Everything's in the same spot except for we have parentheses or absolute value bars, and the quadratic has a square, but aren't the A's, H's, and K's in the same spots? Yeah. So I should be able to give you any function I want, and you should be able to tell me what is going to happen to the graph. What? No. Okay, so is this example 1, because we haven't actually done one yet? Yeah. Example 1. Describe the transformations and translations. So remember, translation is just a fancy word for the shifts. Transformation, it's transforming the arms, so the slopes are changing and it could flip. Y equals 4 absolute value x minus 2, close the absolute value, plus 5. We drew the basic parent function up at the top, which is just y equals absolute value x. The vertex was at the origin, and we had nice arms with a slope either positive 1 or negative 1. What's different about this graph? What does the 4 do to the graph? It does multiply. What does it do to the graph? Vertical stretch. It gets steeper by a factor of 4. So if I was to describe this, I would say vertical stretch by a factor of 4. Because 4 is greater than 1. Okay, I want you to turn to your neighbor and give them 4 words of what this minus 2 does to the graph. In 4 words, you should be able to explain what minus 2 does to the graph, because it does the same thing had this been a quadratic. Okay, who thinks the other neighbor knew what they were talking about? Okay, Connor, what does your neighbor say? Horizontal shift up 2. Okay, first of all, horizontally. Horizontal has to be right or left. I agree with horizontal shift. I don't agree with up. What did she really say, Connor? But which direction, right or left? If it says minus, we're going to go right, because it's opposite, same. So let's change that up to right 2. Okay? Now change your neighbor in 4 words. You should be able to explain. Boys, you too. I keep seeing phones. Put them away. In 4 words, no, behind you. 4 words, explain to your neighbor what the 5 does to the graph. What does the 5 do to the graph? Boys, turn, and talk about what does the 5 do to the graph. 4 words. Okay, what do you think? Thumbs up or thumbs down? Vertical shift up 5. Good? Or we need to fix something? I don't see very many people responding. Put it up high so I can see it. Good, or I need to fix something. Vertical shift up 5. Yeah, good. Because it's supposed to be same, right? Now, does everyone have a calculator? Let's actually see if the graph, and learn how to graph these, and see if it did in fact go right 2 and up 5. So turn your calculators on, please. If you don't have one, go get one. Oops. That's what we're going to learn. Okay, turn it on. Go to y equals. Clear out the old stuff. First, I need Bryson to stop talking. Second, we're going to type in the parent function, which is absolute value x. Well, anyone see an absolute value sign on your calculator?
No.
No. You have to... Shh, I really don't want to keep talking over you. You have to go to math. Hit the math button. Math button's right below the green alpha button. And then you need to go over to the right where it says num, numbers, num. Go to the right, do you see absolute value? Abs. Okay, so again we hit math, and then we went to the right to numbers, and then select number 1. Absolute value, x, close the parentheses. Now I'm going to arrow down to y2 because I'm going to put our new function in. Our new function was this one, for absolute value x minus 2 plus 5. So let's type in the 4. Oops, it got dark again. I don't know why it gets dark. Okay, 4, absolute value. How do we get to absolute value? Math, number, abs. And this was, I forgot what it was, x minus 4? X minus 2? Close the parentheses before you put the plus 5. Was it plus 5? Yeah. Close the parentheses before you put plus 5. Jocelyn, did you get whatever question you had worked out?
Well, because mine, it shows, the absolute value.
Cool. That's fine. Alright. You guys, especially over there, I need you to stop talking, please. Now hit graph, assuming you all have the same window. If you don't, just go to Zoom Standard. The first one, graphed, was the parent function. That looks like the one we already put on our notes. The second one is up here in the corner. Did it in fact go right 2 and up 5? Meaning the vertex moved, right? And is it skinnier? Is it steeper? Okay, what's the problem back there? Are we not able to graph this? The vertex moved right 2 and up 5. And you can see that the arms are skinnier because it's been stretched. The arms came in steeper. Yeah? Well, pass your calculator over here, please. I can't know what's going on until I see it. You don't have a shift in. You didn't. Oh, I bet your window's off. Go to Zoom Standards. Zoom number 6. And then it'll probably be fine. Okay, back to your notes. I'm going to give you another one, and you're going to, again, describe the transformations. Did that fix it, Jocelyn? 4. Okay, describe the transformations. Go ahead on your paper, list them out. Did it work? Okay. Yeah, you can't have those plots on at the top. You turn all those plots off. There you go. Describe the transformations. List what A does, what H does, what K does. So you should be describing 3 different things. Is this an absolute value function? Were you able to get your graph? Yeah. Is this an absolute value function? No. What type of function is this? It's not linear. It's quadratic. But it doesn't matter because it does the exact same things that the absolute value does. The AH and K affect the graph the same way. You should be describing what A does, what H does, and what K does on your paper. Describe what A does, what H does, and what K does. So far, all right? No, I don't have an understudy. What does A do? What does H do? What does K do? It is there. This is not A. I mean, this is not a horizontal shift. No, A is not 0. One of them is 0, but it's not A. Let's do this. Fingers up in the air. What is the value of A? Fingers up in the air. What's the value of A? Good. A is a multiplier. A is not 0 in this case. A is -2. What does that do to the graph? It flips because there's negative. It also does something else. It's a vertical stretch by a factor of 2. Because the absolute value of A, the absolute value of -2 is +2, and 2 is greater than 1, right? By a factor of 2. So it flips and it's a vertical stretch by a factor of 2, meaning it gets steeper twice as fast than the parent function. Okay, fingers in the air. What is H? What is H? Caesar and Landon have it. What is H? H is 0. There's nothing in parentheses with the X. So H is 0, which means the horizontal shift is none. There is no horizontal shift. What is K? Fingers in the air. What is K? Good. That's better. Okay, in 4 words. Who did it last time? Connor last time. Connor, pick someone, please, to tell me in 4 words what the 4 does to the graph. Caesar, 4 words. Is that correct? Yeah, because this is same, right? And since it's positive 4 is in the vertical direction. Okay? So when it says describe the transformations or the translations, that's what you need to do. Also, we'll be doing reverse. Given the graph, write the function. So example 2, given the graph, write the function. Okay, copy this graph if you would, and I'll try to give you exact points. That's not very straight. Let me use the real tool. Okay, this point is -3, -4. Plot that point, please. -3, -4. Also plot -2, -5, and -4, -5. -2, -5, and -4, -5. Given the graph, we need to write the function. Okay, Carly, what type of function is this graph? Absolute value. See how it's a V shape or absolute value, and value has a V. That's one way to remember. Quadratics are the curved U's. Okay, so we have to make sure we have absolute values in our graph. Okay, Sammy, what is the vertex of this graph? Good, -3, -4. We use -3, -4 in our vertex form of the function. Y equals, leave a space for the A, X, something, something. Opposite, same. Okay, Chris Herrera, what would go here next to the X? Now, how come it's +3? Opposite, yep. Sean, what goes after the absolute value? Because why? Is what? And this guy is opposite, and this one is same. Yep. Now, the tricky part is finding the slope. Absolute value has linear arms, so the slope is constant on the left side, and then it's a different constant on the right side. Ooh, probably different color. So the slope, what is the rise to get even with those 2 points? No. 2. So, but it's down, so it's -2. And then what's the run? So the slope is -2/1, which equals -2. The slope can be the tricky part. Because we were at -3, and we went down to these points are at -5.
-4.
Oh, then I wrote these points wrong. 1, 2, 3, 4, 5, 6. That's supposed to be a -6. My intent was to make it not a 1. So just put an extra tick mark in your graph, and then it will be -6. No, you just put an extra tick mark in your graph, and you're fine. Okay? I'm sorry. The intent was to not make it a 1. So we go down 2 and right 1, which is -2/2. Okay, so be careful in the slope. That can be the part where I will throw you off. Okay, so your assignment is using the A, H, and K, reviewing those on all the functions, quadratic and absolute value, and then spending some extra time on absolute value. So the first section is on all the families of functions we've done, linear and quadratic. Oops, that's not a page number, that's the section number. The page is 326, 1 through 18. And then the second page is just specifically on absolute value. Just a couple of them on absolute value. 2 through 20 even. The first one is all, the second one is even. Yes, Davis? Yep. Guys, good.